Hi, everybody. My name is Jamie Motherall, and I'm a functional testing specialist and product marketing manager here at Parasoft. Today, I'll be walking you through Parasoft's AI-powered static analysis triaging workflow using Parasoft's reporting and analytics platform, DTP, and our static analysis solutions for Java, C#, VB.NET, C, and C++. So let's jump in. Parasoft offers 5 AI ML-based techniques to reduce static analysis noise and accelerate the remediation process for development teams. We start by streamlining the triage process for static analysis findings through the automation of the classification of noise. We then use AI to help you to group violations by root cause analysis. We then analyze past user remediation actions and provide AI recommendations on what violations to assign to which developer based on their skill sets. AI performs a CVE match analysis to provide recommendations on which violations are likely to be true security vulnerabilities in your codebase. And then finally, we use generative AI to generate code fixes for static analysis violations in the IDE. So let's dig a little deeper. Let's start with the automation of noise classification. Parasoft DTP's AI analyzes past triage actions taken by the development team, focusing on what violations the developers prioritized to fix build to build and which they chose to suppress or ignore. It then applies a model to all new violations that group violations by the probability factor that they'll either be addressed and fixed or they'll be ignored. This helps teams to determine what static analysis violations can be classified as noise and filtered out. You see, not every finding is something that a developer might consider important enough to change the code for. And it's typically these findings that get labeled as noise. So this filtering process helps users to focus on the most important issues and fix those first. The next AI optimization we offer is helping users to group violations according to root cause analysis. DTP's AI performs a root cause analysis to identify where there are common problems across the code. You see, in many cases, a common problem in the code can actually be associated with dozens or even hundreds of violations. Our AI detects them and groups them into what we call hotspots. This allows management to assign a cluster of violations as a hotspot to an individual developer for remediation. Once the problem is fixed, it addresses the whole group of violations. In this way, developers can get a better return on the investment of their engineering hours, fixing multiple problems in one go. This also reduces the likelihood of work duplication across the development teams. Now, the next AI technique groups violations according to developer skills. DTP's AI builds profiles of developers based on what violations they have fixed in the past, and it learns about their skill sets. So when the next violation comes into the system, it can provide a prediction as to who would be the best developer based on their past experience and skill sets to handle the new violation. So it groups based on skills and then distributes to those developers. So how does this actually optimize the remediation process? Well, violations from the unordered queue are now automatically clustered according to developer skill sets, helping developers to know immediately which of those violations they should focus on for remediation. Developers get recommendations that are matching their personal skills and preferences. And that helps them to become more productive because they're working on problems that they feel confident and comfortable in fixing. This also improves that overall developer experience of using static analysis. Next, we perform a CVE match analysis, and this is actually using one of DTP's optional integrations with LLMs, such as OpenAI or Azure OpenAI. CVE Match uses the AI to analyze reported security violations in your code base and compares them to examples of real instances of that reported violation. It then provides a probability analysis of if the violation is a true vulnerability that should be prioritized for remediation, or if it's likely to be a false positive. This helps developers to focus their engineering time and effort on fixing real security issues in their code base. Finally, we use generative AI technology to rapidly create recommendations on code fixes for violations. This also requires an integration with popular LLMs such as OpenAI or Azure OpenAI. And when a static analysis violation is found, the developer within their IDE can click a button to generate a code fix. They'll then review that code fix, and if everything looks good, they can click another button to automatically apply that code fix to their code base. So to recap, Parasoft DTP offers AI-enhanced widgets that display static analysis classifications results based on past triage actions. As certain violations are prioritized and others suppressed or ignored build to build, the AI under the hood analyzes these decisions and stores them in historical data for future prioritization. The AI learns from these triage actions and is able to then provide recommendations on how to prioritize other static analysis findings for remediation. Having a way to easily classify findings based on the probability of the violation being fixed or ignored can make a big difference in accelerating the remediation process and reducing the burden on development teams. As you can see here, when we first ran our scan, we had 5,000 static analysis violations reported. The AI sorted the findings based on the data it learned from analyzing past development team triage actions, and it grouped the findings to make it easier for the team to understand what violations should be prioritized. So we've gone from 5,000 violations to actually only around about 500 that need to be looked at for remediation. Next, DTP's AI also will analyze the root cause of static analysis violations and group those related violations together into hotspots. This allows development managers to assign a cluster of static analysis violations to one developer who will fix the code addressing all the violations at once. This, of course, is streamlining the remediation process. And again, it reduces work duplication across the development team. DTP's AI will also then analyze past triage activities and take notice of what types of violations specific developers tend to remediate. When assigning violations back for remediation, management is then provided with actionable AI recommendations on who to distribute which violations to. This way, violations are assigned to the developer that has the right skill set and knowledge to easily remediate them. Finally, we get to our LLM-based capabilities. The CVE match analysis provides a probability analysis to help developers reduce their time spent on false positives. And then we have our generative AI fixes that quickly remediate the violation and allow the developer to get back to writing new code. Now, keep in mind the ultimate goal here is to maintain developer velocity while improving code quality and security. By reducing the time and effort spent triaging static analysis results, teams can focus on fixing the issues that truly matter to their project. This not only boosts productivity, but it also frees developers to spend more time on doing what they do best, building innovative, high-value features. Thank you for your time today. If you're interested in more on Parasoft static analysis or our AI solutions, please go to parasoft.com and check out our solution pages. Have a good one. Until next time.